Whatever engineering problem you have right now, the solution is probably not to write a new programming language. But sometimes it does make sense. JetBrains makes IDEs, the interactive development environments that many people code in, like IntelliJ and WebStorm, and all of these IDEs are written in Java. So the JetBrains team is very familiar with Java and the other JVM languages that are written around the Java ecosystem. Since JetBrains spends so much time working on tooling for developers, they also have an intimate understanding of the problems that developers encounter, particularly in the programming languages that they work with. Kotlin was developed as an alternative to JVM languages such as Java and Scala. In this episode, Hadi Hariri from JetBrains explains why the company decided to build a new JVM language. We discuss many of the features of Kotlin, such as safety, concision, and its ability to compile to JavaScript. This was one of the most recommended topics that I do an interview on for Software Engineering Daily. And if you have recommended topics, please send me an email, jeff@Software Engineering Daily. And without further ado, let's get on to Kotlin with Hadi Hariri. To understand how your application is performing, you need visibility into your database. Vivid Cortex provides database monitoring for MySQL, Postgres, Redis, MongoDB, and Amazon Aurora. Database uptime, efficiency, and performance can all be measured using Vivid Cortex. Don't let your database be a black box. Drill down into the metrics of your database with 1-second granularity. Database monitoring allows engineering teams to solve problems faster and ship better code. Vivid Cortex uses patented algorithms to analyze and surface relevant insights so users can be proactive and fix performance problems before customers are impacted. If you have a database that you would like to monitor more closely, check out vividcortex.com/sedaily to learn more. GitHub, DigitalOcean, and Yelp all use Vivid Cortex to understand database performance. At vividcortex.com/sedaily, you can learn more about how Vivid Cortex works. Thanks to Vivid Cortex for being a new sponsor of Software Engineering Daily, and check it out at vividcortex.com/sedaily. Hadi Hariri is the VP of Developer Advocacy at JetBrains. Hadi, welcome to Software Engineering Daily.
Thank you. It's great being on.
JetBrains is a company that makes IDEs. These are development environments like WebStorm and IntelliJ, and these IDEs are written in Java and other JVM languages. And the JVM has many languages written on top of it, but JetBrains decided to create another, which is called Kotlin, and that's what we're discussing today. But before we get to what Kotlin is, there are probably some people listening who are unfamiliar with Java and the JVM. Can you give an overview of the JVM ecosystem and how that works, why languages are built on top of this ecosystem?
Yeah, sure. So the JVM is basically a virtual machine onto which you have different languages that you can write code in. And all of these languages essentially get converted into bytecode. And then the bytecode is what runs on the virtual machine. So it gives you that layer of abstraction so that you're not actually having to create different compilers for different languages to run on native. It runs on this virtual machine, which also gives you a bunch of other benefits such as garbage collection, etc. And given that you've got a plethora of languages, many languages running on the JVM, a lot of times you end up where these languages are interoperable. So, if I'm using, for instance, Kotlin, I can interop with another language such as Java or Scala or something else.
Okay, so when we hear about these languages being built on the JVM, for example, Scala, what does it mean for a language to be compatible with the JVM? What exactly is going on there?
So essentially, any language that is compiling down to bytecode and thus being able to run on the JVM, so is effectively compatible with the JVM. I mean, there's a the JVM comes with a couple of implementations, and then it comes with a bunch of specifications, and essentially you have to comply with these specifications. Having the compatibility between languages is a little bit more difficult. So there are some languages where it's harder to be compatible between two. So let's say, for instance, if I'm working, I don't know, with Scala and Java, just to name a couple, while both of them are effectively compiling down to bytecode, there's a little bit of differences in terms of API usages and that. So it can cause a little bit of incompatibility. In the same cases for Kotlin in very, very extreme cases. But Kotlin has been focusing more around providing that interoperability with other languages such as Java.
So Kotlin came out of the decision to write another JVM-based language. What were some of the shortcomings of the other languages in the JVM ecosystem? Because there's a ton of languages. Why wasn't there one that fit your needs?
So when we started Kotlin, to give you a little bit of background, I mean, you mentioned that the majority of our tools are written with Java running on the JVM. So we've got kind of two sets of tools. We have the IDEs, and then we've got a few tools on the .NET side, namely ReSharper, and then we've got some back-end server tools such as TeamCity, etc. Anything that is not ReSharper or our .NET tools, most of them are being written in Java. And we've got, at the time when we started Kotlin, it was 2010, so we had over a decade of code base. And if you're familiar with Java, you know that it's not very concise in terms of a language. And there was a lot of things that were going on in other languages that we felt we could use. So, namely, things around Lambdas and functional constructs, which we thought this could be beneficial to us. The problem is that at the time, there was really only a couple of main candidates for us to choose from. One of them was Scala. And we actually create a plugin for Scala. So we know what the effort is involved in tooling Scala, and it requires a lot of effort. Not only that, at the time, now it's better, but at the time, the performance of Scala, the compiler, was very slow. So we discarded Scala for those two reasons, and another one, which is Scala is an extremely powerful language in that it allows you to do a lot of things. So you can take, for example, any symbol and override it. And this is very powerful, but at the same time, it does pose a risk, which is, given that the language doesn't give you a lot of constraints, you can do many, many things. And this is a problem that people, mostly admit that they have encountered with Scala, in that as the size of the code base grows and there isn't really a set of guidelines that you should follow when you're writing code, you can turn the code into something quite complex. And we wanted something that didn't really allow for that. We wanted a code base that was concise, that was readable, and was maintainable. So, having discarded Scala, we kind of basically thought, well, maybe it might make sense for us to start our own language. And really that was where Kotlin was born.
And as I understand, another side of this is that Java is very verbose, and you kind of wanted to get away from the verbosity of the Java specifically, perhaps other languages in the JVM. How does Kotlin kind of alleviate the shortcomings of the verboseness of Java?
Well, there's a few things that we try and do differently in regard to Java. So, for instance, there's certain constructs that make it much more concise to create certain types of classes, objects, functions, etc. To give you an example, one thing that a lot of people are continuously using, and many of us use as we're writing code, whether it's application servers, whether it's database applications, anything, are the concept of a Java bean, which is essentially a class that has a bunch of properties that has, you can read to them, you can write to them, then it has a few methods, etc. It's got the ability to do a toString to represent the class as a string, or equality to compare two instances of the same class, etc. So if you look at a Java bean, this can be well into the 30, 40 lines, obviously depending on the number of properties that you're talking about. But for essentially for any property, you're going to have a getter, you're going to have a setter, and then you've got to take this into account when you're doing the toString, when you're doing the equals, etc. So a lot of IDEs, including IntelliJ, for instance, help you with this, right? You create a bunch of fields, and then you tell IntelliJ or your favorite IDE, go ahead and generate all the properties, getters and setters for me, and generate the toString and the equals. Now, that's a lot of code, but you say, okay, well, it's generated, so why do I care? There's two issues there. One of them is that generated code is going to remain in your code base. And if you, for instance, update a class by adding a new property, you got to regenerate that code. The other issue is that you don't know until you open up that class and you look at it, you don't know if that is the standard generated code of the IDE or the whatever you're following to generate that code, or is it tweaked? So these 30, 40, 50, 100 lines of code, which, as I said, varies depending on the number of properties, we do that in Kotlin essentially with a single line of code, right? Where we just create a class, define a series of properties. On the same line where you're defining the class, you can also define the constructor. And then Kotlin takes care of generating, not generating, but providing at runtime all of the different things that you would get in the equivalent Java version by having to write it or generate it yourself.
Okay, so I actually want to take a step back here, because I should have asked this first, but more generally, when is it worth it to build an entire new programming language to solve a problem? Like, what is the general class of problem type where you need a new language?
Oh, that's a difficult question, because I think that it rarely calls to invent a new programming language, which is strange for me to say given that we've done it. But there has to be a lot of there's got to be a lot of business reasons behind you doing that. Because, even let's take another step back and let's not even talk about programming languages for a second, but any kind of tooling or any kind of framework, anything, right? We as developers have this tendency of reinventing the wheel, with the not invented here syndrome, which is, well, there's a framework that does, model view controller for the web. Let me just go ahead and create another framework. And someone else sees it and says, well, I can do better. I'll go and create another framework. We've got thousands of examples just in JavaScript alone with packages, etc. Now, the thing with the language is that it's way more involved, right? Languages are something that have to live. If you're serious about it, first of all, it's extremely costly. You're not going to get an immediate return on investment. You have the high risk that the language will not be popular. You have the high risk that as language is not popular, you're not going to get adoption. If you don't get adoption, you don't go into that feedback cycle. So you don't know if you can improve it, or you're just using it for your own specific case and not seeing a more general approach to solving problems. It's very, very costly. So I would say that if there isn't a valid business reason behind it, probably in very, very rare occasions would you go ahead and create a language yourself. Now, in our specific case, we had several reasons. We wanted a language that was more concise to cut down our code base. We had 20 products. We needed to continue to write these products, maintain these products, cut down the code base. We also believe that there's better ways to do things. So our focus as a company that develops developer tools has always been to try and do things in a more efficient way, in a more productive way, so to speak. And we thought, well, we're doing all of these things with tooling. Why shouldn't we try and do this also with languages and provide a more efficient way to do certain things? And then, of course, being a company that provides tooling, we also saw an opportunity there that obviously if we create a language and the language has adoption, we can create tooling around it as well, which at the end of the day, that is our business. We sell tools. So I think first and foremost, there has to be valid business reasons for you to ever even decide to embark on creating your own language.
And with that in mind, what is the business reason for Kotlin? I mean, let's reiterate this. Like, where would I use Kotlin? Why would I use Kotlin?
So for Kotlin, we try to create a language that's basically industrial in the sense that you can use Kotlin in any type of scenario, whether it's creating a web application, whether it's creating a web server, whether it's creating a desktop application. Effectively, we create desktop applications. So first and foremost, we wanted Kotlin for ourselves. So, it is appropriate for desktop applications. What happened though is that at some point we started to say, hey, there's a market which is called Android that they're using Java mostly. And maybe we can try and see if we can provide them support for Kotlin as well. Now, when you're talking about Android, you need to take certain things into account, like the library size, like the footprints. And so we started to tweak it a little bit and say, let's try and target Android as well. And that suddenly started to take off. So we invested more into supporting Android. But in a sense, I'm not going to say backfired, but it has kind of, in a sense, backfired in that a lot of people think that Kotlin is a language specifically targeted at Android, which is far from it, right? Kotlin is a very general purpose language, exactly the same as Java, exactly the same as C#. So you can use it in any kind of scenario for any kind of application.
Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. Let's get into the features of Kotlin. We already mentioned that Kotlin is less verbose than Java. What are some of the ways that make it more concise that we haven't mentioned yet?
So one of them the quick one that we mentioned was Java Beans. Then there's a lot of things. For instance, let's say you are writing casting objects, right? A lot of times you have one type that you want to cast to another type. So many times in your code base, you're doing things like checking if a specific object or instance is of a specific type. And then if it is, then you have to explicitly cast it to that type to then have to, operate on it. The conversion and the typecasting to another type to then be able to call the methods or the properties or what have you. So that's another thing that Kotlin cuts down on, right? If the compiler figures out that if you've made a check to see if a specific object is of a specific type, then you no longer have to explicitly do a cast. I will automatically cast this for you. I'll smart cast this for you. In other terms of being concise, the way that we write Lambdas, for example, anonymous functions. Now, up to when we started working on Kotlin, the concept of Lambdas wasn't present in Java. It only came around in Java 8. So writing single abstract methods, which was basically effectively an interface that you just had to implement just because you wanted to call a single method on it, was a lot of verbose code. And in Kotlin, you can just pass a function. Effectively, you have support for higher order functions, so you can have functions that take functions as parameters or return functions as parameters. So it's a few different things that allow you to create much more concise code. Now,
and packaging too, right?
Pardon?
packaging too, right? Like the packaging syntax when you're importing a package into your Java. I mean, I just remember like working in big companies with lots of Java packages, and you have to do com dot whatever dot whatever dot whatever dot whatever, and it looked like the packaging syntax for Kotlin is a lot more concise.
Yeah, so one of the things that it is concise, but at the same time, so what we do is actually we recommend that people follow the same kind of conventions as in Java. So, it's the reverse domain and then the package name ... which I refer to as death by 1,000 folders, right? But so you still do that. However, it is not enforced. So for Kotlin, you don't have to align your package names with actual folder names. You can, organize things any way you want. And then this is another thing, a convention that we kind of try and bring in from other languages, namely C#, for instance, is that in the C# world, when you're using different symbols of a specific package, you're not individually importing these. So you don't have to do import org.jetbrains whatever, and then another one exactly the same for the last symbol to be different. You just do an import jetbrains.star, and that imports everything. And we try and follow that convention as well, some of us at least. And again, the IDEs also help you with that and say, convert all of these individual imports into a single import. But that is kind of a convention that is deeply grained into Java, so it's kind of hard to break. So
yeah, the sorry to interrupt you, but the star import, like you're not supposed to do that in Java, right? Like I feel like I have gotten like pull requests rejected because you're importing star, don't do that.
Which is crazy, right? Because in fact, there's I'm sure a friend of mine that he's a great speaker. His name is Kevlin Henney. Right, he's one of the members of the C++ standards and awesome guy. And he's got this talk in which he says he's talking about exactly this star import thing, right? And he goes to Stack Overflow and asks this question, like looks up this question of like, why in Java am I doing a star? Am I not allowed to do a star import and I have to do individual imports? And the top 3 answers to that question are, you don't have to worry because an IDE will take care of it for you. And no one's really answering the question of like, where did this come from? Like, why do I have to do this? And it turns out that in certain specific cases, very rare cases, namely, I think it was swing namespace, there could be a conflict.
Oh, right.
Right? So because of like, this is really like the minority taking over the majority.
Yeah.
Of like, because of this unique specific case, let's just import everything one by one, which is crazy.
What a weird historical accident.
Totally.
Okay, so another appealing feature of Kotlin is safety. We did a show about Rust concurrency recently, and we had a great discussion of safety in that show if listeners want more on the safety topic. But what does safety mean in the context of a programming language, and how does Kotlin accomplish that safety?
Well, in our case, when we're talking about safety, namely, we're talking about nulls. So as you know, Java, C#, many languages deal with nulls. And when you declare an instance of a type, by default, that type, the instance can have the value null, or referred to as the $1 billion mistake. In Kotlin, by default, we don't have nulls. So that means that when you declare a variable, that variable cannot be null. And thus, you would essentially never get a null reference exception at runtime, because you would never be able to, do anything with that. Since the value can never be null, it's never going to happen. Now, Kotlin does allow you to declare things as nullable. And when it does, it will also enforce that through a compiler error, saying that, this is nullable, and therefore you cannot just call it the way you're calling it. So in regard to safety for us, it's in that aspect mostly.
Now, how does the functional programming support in Kotlin work?
So one of the things that we do in Kotlin is essentially treat functions as first-class citizens. And that means a couple of things, but to begin with, you can just declare functions. So if you look at C# or Java, you cannot have top level functions as such, like you do in JavaScript. In JavaScript, you can open a file, declare a function, and you're done. In Kotlin, it's exactly the same. I can just open a file. I don't even have to give it a package. It could be part of the package, default package. I can write fun, which is how you describe a function how you start a function in Kotlin, fun, and then the name of the function, and just write it in that file. So it doesn't have to be associated with a class, or be a static method, or a static method of a static class. So that's the first thing. We have the top level functions. The next thing is that we allow higher order functions, as we were saying before. So essentially, you can have a function that takes another function as an argument or returns a function. So this allows you to kind of do functional constructs, so to speak. So, instead of having to declare classes and then instantiating those classes and then passing in those classes to then operate on a specific method of that class, I can just pass in that method, just pass in that function directly. And then we also provide support for Lambdas. So Lambdas or anonymous functions. In Kotlin, we also have the concept of an anonymous function, which is declared slightly differently to a Lambda, but there's Lambdas as anonymous functions. So essentially, and I think Eric Meyer said this best, that because there's always a lot of debate, like what constitutes a functional language and what constitutes a non-functional language. And there are many that have the school of thought that, the only functional language is Haskell and a couple more. Eric Meyer said, essentially, if I can treat functions as primitive building blocks, as first-class citizens, then in essence, for me, that is a language that is functional, that allows me to work in a functional way. And that's something that we try and allow and do in Kotlin.
How does that compare to the functional presentation of Scala, and perhaps, I know Java 8 has some, I think, functional-like features. I don't know Java 8 very well, but did Kotlin take any inspiration from Scala or from the Java way of looking at functions?
Kotlin took inspirations from a lot of languages, including Scala, C#, Groovy, I think a little bit Java. I don't think Java 8, because Java 8 kind of came out afterwards. But so there is a lot of influence from different languages. It is, if you compare it to Java 8, which does allow Lambdas and higher order functions, I would say it's more concise. If you compare it to Scala, it's pretty much in line with Scala. But when it comes to comparisons with C# and Java, I would probably say that Kotlin is more concise. And there's another aspect that Kotlin has, which is extension functions, which is somewhat related to functions. If you want, we can get into that.
Sure, let's do it. Tell me about it.
Yeah, so a lot of times if you take a look at a class, right, essentially, if you want to extend that class with certain functionality, what you need to do is inherit from that class and add another method or what have you to it. In C# there was this concept called extension methods, which essentially allowed you to add a new function, a new method to an existing class without inheriting from it. And we have the same concept in Kotlin. So
this is on the fly, you're adding functions.
Well, no, it's resolved at compile time. So it essentially is kind of like a static method on that class. But what it actually acts as like an instance method of that class, because you have access to the instance. But you can actually, so when you're using it, when you're writing code, it's imported statically, that function, that extension function. We've taken it one step further in that we also provide you the ability to create extension properties, not only extension functions. So you can take any class, be it a Java class or a C# or a Kotlin class, and extend it with new functions and new properties. And that,
why would you do that?
For many reasons. One of them, for instance, for readability. Another one for conciseness. The same things that we've been trying to target at with Kotlin. It's for the same reasons. Let's say that you have a class that you've got I don't know, 3 methods to like a typical example that they put. Like, okay, let's take a string class, right? And I have the string and I have a 2 uppercase and a 2 lowercase. And now I want to do a 2 camel case, right? What are my options there? I would have to create a function that takes a string as a parameter and returns a string that converts that function to a camel case, right? Whereas if I extend, but then when I call that, I would have to call the function as kind of like a standalone thing passing in the string. Yet, if I'm writing code to, for example, create a convert a string to uppercase, I could just put the name of the string, the string dot to uppercase. I would like to have that same kind of functionality. How can I accomplish that? Using an extension function. I now create an extension function which is called toCamelCase, which allows me to invoke it on any instance of a string. So I keep the same kind of style when I'm writing code. It's more concise. I don't have to have some other way of calling code. And these extension functions, essentially it's around readability and maintainability, because I don't have to neither create a standalone function somewhere else or create a new class that inherits from my string class that I could call my string that has a toCamel case. I don't know if that makes sense. It's kind of hard to explain code when
No, this is the classic challenge of doing a podcast episode about programming languages. But let's shift the topic of conversation a little bit. So we're talking about Kotlin, which is this language that is on the JVM. It's interoperable with Java. When I compile a program that has Kotlin code and Java code, what are the stages of that compilation process? Where is the point where, or I guess I don't know if you want to call it a build process, or what exactly is it? Like, what are the stages, and where is the point where both of these languages are in a bytecode that is indistinguishable?
So both of them have a compiler. You have the Java compiler and you have the Kotlin compiler. So if you're writing Kotlin code, it's going to go through the Kotlin compiler, and then it generates a .class file, which is essentially the bytecode, which then is run by invoking Java and then the class file on the JVM. If you're doing Java, it's the same exact thing. So it really is down to where those phases are and at what stage happens. It very much depends on the build system you're using. Now in Java land, there's a couple of build systems. There's the more famous ones that are known are Ant, which is kind of now a little bit antiquated. But there's Maven and there's Gradle. So Kotlin does allow for mixed projects. So you can mix Java source code and Kotlin source code. So if you're doing that kind of mixed project where you have these two languages and you're using something like Gradle or Maven, you have different plugins to apply to compile the different source code files. So, I would have a plugin that would compile all of my Java source code, and then I would have a plugin that would compile all my Kotlin source code. In the IDE, because one thing is compiling and then generating the bytecode and then running that, at the end of the day, all of it is going to generate bytecode. But in the IDE, we also, the Kotlin plugin itself is aware of your Java source code. So it provides you with the completion, it provides you with parameter information, the type checking, all of these things as part of the plugin. But the compiler just happens in you have your Java compiler and you have your Kotlin compiler, and they just each do their own job.
I want to talk about the JavaScript aspect, because Kotlin compiles to both the JVM and to JavaScript, which is something we have not discussed. Why did you build it that way? Why would you build a language that compiles both to the JVM and to JavaScript? Because
everyone was doing it. Is that a valid answer?
Sure, that's a valid answer.
Essentially, so here's the thing. It's half true, but it's like a lot of people were... right now, a lot of languages are transpiling to JavaScript, right? And what we kind of saw is, maybe we should try this out as an experimental thing. And in fact, in the 1.0 release, JavaScript compilation was still very experimental. I mean, in fact, every time you started a new project and you're compiling, targeting JavaScript, it actually says to you, this is experimental. In 1.1, which we went out with the beta today, it's now production ready, so to speak. So in the 1.1 release, will be production ready. And the reason we did this was, so we have this language which is very nice and terse on the Java side. There's a lot of people doing web development. And, why not provide this kind of language to generate JavaScript, which enables people that actually like the language to target JavaScript, and either whether it's server-side JavaScript through Node or whether it's, client-side through the browser. But it also enables us to do mixed projects. So a lot of times when you're doing a web application, you end up with a lot of code that is duplicated in terms of business logic. So I'm doing validation on the client side for an object to make sure certain properties are met. I've got to do that same validation on the server side. So now I have Java code to do the validation on the server side. I have JavaScript code to do it on the client side. And we thought, well, if we have this single language that can generate both JVM bytecode as well as JavaScript, you can effectively just write once certain parts of your code base and target multiple platforms. So, we saw that there's potential and we decided to go ahead with it.
I saw a talk where you said there are some good use cases for combining Java and JavaScript, and I didn't exactly know what you meant by that. And maybe you just answered it and I didn't fully understand it. But I thought we were typically keeping Java on the back end and JavaScript on the front end. When are we going to want to combine these two things?
Yeah, so it was kind of like the example I just gave, but let me give a little bit more detail. So,
okay.
First of all, I think that kind of idea has basically evaporated when you look at something like JavaScript and Node, because a lot of people are actually using JavaScript on the back end as well.
Okay, true, yeah.
But let's say that you have a Java application, right, that is, dealing with bank transfers. Now you have some business logic on the back end that makes sure that when you want to initiate a transfer, you have to give an origin account, a destination account, and the quantity that you want to transfer, right? And when you call that API on the back end using Java, you got to validate that these values are in there and that they're greater than 0, etc. So you've got that on the back end. Now you go ahead and you do the front end and you're using something like AngularJS and you got a form. And when that person submits that form, they're going to have to check also that those values aren't blank and that the quantity is greater than a certain amount, 0 or what have you. So that code right there, you're going to have to write in JavaScript on the front end. And the same code you're going to have to write in Java on the back end. Now, this is a very simple case where you're just checking to see a single value is greater than 0. But imagine a little bit more of a more complex scenario in which you have certain business rules that your input values must follow. That's a perfect scenario where you could actually write this a single time using Kotlin and have that same business rule validation engine, or whatever you want to call it, generate bytecode, meaning that it can validate the input on the server side, and generate JavaScript, meaning it can validate the input on the client side. So you write once and use it on both, on the back end and the front end. Does that make sense?
It does make sense. Now, let's zoom out again. What is involved in writing a new JVM language? What kinds of strategizing do you do? What's involved in the design process? What kinds of tooling do you have to build? Give me an overview for what that process is like.
Oh, that would be a little bit difficult for me, given that I'm not on the team that designs it. You probably want Andre to get him on board to talk to you about that. But it so happens that I was recently discussing this same thing a little bit with him, and I think that as he was saying, the biggest challenge is you come up with a lot of ideas, but taking those ideas to implementation and making sure that things are working and making sure that you've looked at all of the different edge cases, and when you're trying to do things like interoperability, it takes a lot of effort, and it's not something that you can do quickly. To give you some idea, when we started Kotlin, it was started 6 years ago. It released 6 years later, right? So it was started in 2010, and the release happened in February of 2016. And during this phase, there were a lot of design decisions that were made in the language that were then taken back. I mean, not a lot, but there were quite a few that were reverted or dropped. And this was why it was kind of done on purpose. The reason that we took so long to release is because once you design a language, once you hit 1.0, it is extremely difficult to drop features. You can't just say, we screwed up on this one, let's drop this, and let's drop that, and let's drop this, and let's drop that. Because people are depending on your language for their code bases, and they don't want to constantly have their code bases break compatibility every time you drop a feature or what have you. So you got to make sure that what you're doing is valid and well thought out. And the way that it was done at JetBrains and on the Kotlin team was, let's give a good period of time in which we'll release Kotlin, people can play with it, they can test it, they can try these language features, and if it is not exactly as we thought or they thought, or we didn't see some potential issues, we are still at time to address these before we hit 1.0. Because when we hit 1.0, we really want to keep the language stable. So I think that if I were to look at it like from a perspective of would I ever design a language, I definitely would not. But I think that it involves a lot of it's you've got to be like, as I say about Andre, like when I talk to Andre about a certain feature, right? It's very funny because I come and I say, hey, Andre, that C# has this, we should have this or this. And he's very, very receptive to the idea. And he makes you think about it, reason it out, and then it clicks for yourself and saying, yeah, exactly. I didn't think about this, and that. So it takes a lot. One of the good aspects that he has, and I think this is a good characteristic to have as a language designer, is you have to be conservative but open to ideas. But you really also have to be quite conservative about not adding every single feature you can think of or other people can think of, even if it feels like a great idea, to the language, because you'll end up bloating the language a lot.
Saji is an end-to-end data platform that lets you focus on deriving business value from data. With Saji Present, you can turn your data into a story, easily sharing a presentation from your data lake. Explore data and drill down into details, creating rich visualizations. With Saji Manager, you can easily build data pipelines of jobs mixing Spark, R, Python, and more. Saji is great for predictive analytics, whether you're predicting the failure of a machine in your factory or predicting which sales leads will be the most valuable. Saji helps you take control of your wide variety of data sources and gets them in one place. Check it out at saji.com, SAAGIE.com. Thanks to Saji for being a sponsor of Software Engineering Daily. Now, Kotlin is an open source project. It's hosted on GitHub. How does contribution and governance and pull requests and stuff, how does that work in an open source programming language?
The majority of the contributors to GitHub are more around tooling and bug fixes. So essentially, a lot of the language design is still internal inside JetBrains. It's still kind of part of the team. Now, recently what happened is that we kind of tried to set up this process, which we call KEEP, which is a Kotlin evolution and enhancement process or something like that, where we now document any new feature we want to add to the language, and we document, it's kind of like, you're familiar with the RFCs, the request for comments.
Sure.
It's pretty much the same thing, right? Let's come up with, we've thought of this feature. Here are the different use cases. And then we push that onto GitHub and we let people comment on it. And just as we do that, community can also initiate each of these keeps and say, we've come up with this language feature. What do you think about it? But it's still very much kind of, Andrei Breslav is still mostly the person that decides on what features should go in and should not go in. So a lot of the contributions right now as an open source project are focused around, the tooling and other aspects that the project has.
Let's talk about some of the Kotlin use cases. We've already glossed over the fact that it's works with JavaScript, it works in the enterprise, it works on Android. Let's talk about the enterprise. Let's say I'm an enterprise with a large Java application. Why should I use Kotlin?
First of all, foremost, if you don't have a valid business reason, you shouldn't. But I think that so there's a couple of reasons why you would want to use Kotlin. Let's say, for instance, if you are a large enterprise shop and you're targeting Android, while there is certain level of Java 8 features now working on Android, mostly it is still restricted to kind of like not having Lambdas and certain constructs that Kotlin and Java 8 allow you. So if you're writing Android application, which many enterprises now do because they've got their mobile versions of their software, you would benefit from Kotlin because Kotlin is compatible with Java 6. So essentially it can generate the same language level compatibility with Java 6. So you can use it in Android applications. That's one reason. If you have large code bases that you want to cut down on size, because through our experiments and through the data that other people have given us, we can estimate roughly that you get about 35 to 40% less code by cut down in code size by using Kotlin.
I can imagine that being a productive exercise if the company is deciding, hey, we're going to take some time to refactor certain aspects of our application, and during that refactoring process, you could just rewrite in Kotlin, so you could simultaneously refactor the code and move a lot of it over to Kotlin and get it more concise.
Yes, and given that we have very good interoperability, it's not a rewrite. I mean, when we designed Kotlin, interop was one of the major aspects of it because we didn't want to throw our code base out, right? We couldn't close shop and say, right, we're going to take another 5 years to rewrite our 10-year legacy code base. We had to keep functioning. So we're doing exactly the same. Like, we're not rewriting things from scratch. We're just using Kotlin now and mix and matching areas in Kotlin, and some parts are tests, some parts are new plugins. Our code base is now, there are applications that are entirely now written in Kotlin, some of our tools, but IntelliJ, for instance, is slowly converting things to Kotlin, and they're doing that exactly as you say, precisely at certain times as part of a refactoring. So that is a very good way to introduce it. But one other very good use case, which is one of the strong points of Kotlin, is to do DSLs, or domain-specific languages. So we tried to create a language that allowed us to create that allowed developers to easily create DSLs. So a lot of businesses have business rules. They have their own domains. And Kotlin is a good language that lends itself to allowing developers to create domain-specific languages so that business people and others, even developers working in that domain, could use to describe systems. And that's one of the strong points of Kotlin.
A lot of the people that I talk to that are refactoring Java applications, not to put a finer point, well, I guess just to put a finer point on what I said earlier, a lot of people who are refactoring their Java applications these days are doing like a microservices thing. So this is not like a myth. Like, there's a lot of people refactoring and breaking their stuff out. And I think it would be maybe an interesting exercise to go from your Java monolith to, if you're going to microservices, then maybe you just put those microservices in Kotlin. That would be kind of cool.
Yeah, absolutely. Because I mean that's one of the things of this whole tendency towards microservices as well, right? You want to have this decoupling. You want to be able to have smaller services, each doing a different thing, and each of these could be, you do this in a very polyglot way. You could have one thing in JavaScript, one thing in Java, one thing in Kotlin, whatever. It lends itself very well to this.
Yeah, but although JetBrains making IDEs, an IDE strikes me as something that like has to be a monolith. It's not really something that is a microservices based application. Is that accurate?
Yeah. So in our case, I mean, we have IntelliJ, the platform, and essentially on top of that, we have a series of plugins. And then what we did was, initially there was only IntelliJ. So then we added JavaScript support, and then we added PHP support. And then we started to get demand from people saying, hey, you know what? I don't want the heavyweight or the bloat, which isn't, but I don't want the whole Java package. I just want PHP. Why don't you just give me an IntelliJ for PHP? And that's how the different smaller IDEs were born. But effectively, really what it is, it's just IntelliJ, the shell, the core platform with plugins. So if you want to think about the different languages like PHP, Java, Kotlin, Go, all of these as, I wouldn't say microservices, but small self kind of contained functionality. In that sense, it is not a monolith because it's just every language, every IDE is kind of self-contained in a 2 or 3 plugins that are then plugged into this core platform.
What an interesting company. I do think about JetBrains sometimes. It's like the fact that you built this one IDE and then kind of were able to reskin it, retool it for so many other languages. It's a really great business, and it's a very unique business. Anyway, but Kotlin. So there were more requests for Kotlin, for me doing a show on Kotlin, than I think any previous topic, and I was surprised. I just kept hearing from people, do a show on Kotlin, please. And I was like, I have not heard of this language. And then I looked into it more. And when I was doing research, I read this blog post from somebody who sounded like they had been around for a while. And they said it was going to be their programming language of choice for the next 5 to 10 years, which is a kind of bold statement. Why are so many people interested in the Kotlin language?
Oh, that's hard to answer. I mean, let me give you. I mean, I can give you an answer based on my own experience and probably what I've heard from people, right? When I came to, my background wasn't Java, it was .NET, and before that it was Delphi, and before that it was other things. But when I came to Java, and one of the things that really drove me away from the JVM and the platform itself was the language and the verbosity of the language and certain quirks that really annoyed me about the language, like having to have checked exceptions, having to have these getters and setters for everything. These were things that really drove me away. And it just felt like a lot of boilerplate code over and over again. So when I started to look at Kotlin, it felt very much like C#. But it started to feel better than C# for me because it was more concise than C#. It kind of started to feel for me like a JavaScript that is statically typed, because I prefer static type languages, but it not with the verbosity that I think things like TypeScript have now introduced. But I mean, we were talking before TypeScript even came about. So I fell in love with the language because of its conciseness and how terse it was and how it did a lot of things for me without me having to worry about it. So when I speak to other people and I say to them, like, a lot of times it's exactly the same situation with IntelliJ and Eclipse. People, I go to a lot of shows and I do a lot of conferences, and people come to me and say, hey, tell me, what feature does IntelliJ have that's going to convince me to switch over from Eclipse or NetBeans or what have you? And I say there isn't. Like, let's do a feature by feature comparison. And I'm sure that you're going to say, well, I don't use this feature or I like that feature. I said, IntelliJ feels different. I'm not saying whether I'm saying it's better or not. For me, it's better. For you, it might not be. But it feels different. When you use it, you enjoy it. So I tell you what, instead of comparing features, go spend the month with IntelliJ. Use it, and then tell me whether you want to go back to what you were using or you're going to stick with IntelliJ. And I get that a lot of people say, you know what, I tried it and it worked. And for me, Kotlin, it's kind of the same thing, because there isn't one single thing that I could say, this is the killer thing for me in the language. It is just like, I use the language, I enjoy it, that I really want to continue to use this language. And this is what I start to hear from other people as well. It's just a combination of things that make you feel like, hey, I could use this language for quite a long time. And, I enjoy writing code now in Kotlin.
One of the points that the author made in this article was that, and I'll link to this article in the show notes, but he made the point that these dynamic scripting languages like JavaScript and Go, they can lead to some real problems. Like, because this writer was coming from the Bitcoin space, and in Bitcoin, avoiding monetary losses is something to keep in mind. What are, like, speaking more generally, what kinds of trade-offs should developers keep in mind when they're thinking about whether they need type safety in their language of choice?
Oh, this is a religious war, but let's go for it. So the problem is, depending on who you ask, they're going to give you a different answer, right? There's a lot of people that love static typing. There's a lot of people that love dynamic typing. Dynamic typing, generally, my feeling is that as the code base grows, or let me put this completely differently, right? When you don't have constraints, you can do anything you want. Since you can do anything you want, you then have to you'll run the risk that you can end up with horrendous things, or you have to have discipline to only do certain things. Now, you need to have that discipline, but you also need to impose that discipline to other people, because you don't work in isolation. So you end up having to write a guide of saying, this you can do, this you can't do, this you should do, this you shouldn't do. This is very similar to the kind of like the Scala thing, in that you can do many, many things, right? With a static type language, you're restricted to what you can do. That restriction can sometimes hinder you, but it also allows you to be constrained to certain things. So when you look at code bases, when you write code bases, when you review code bases that are 5-6 years old, it follows a certain pattern, which is the constraints of the language, the being a strongly typed language. In addition, static typing provides you with certain features that is much harder to obtain with dynamic languages, namely tooling. You can create much better tooling, and trust me, as I said, because we do it for both static and dynamic. You can create much better tooling when you have type information with a statically typed language than you could do for a dynamic language. Now, the plus side of the dynamic language is, of course, that it's dynamic. So a lot of times you end up in a situation where the compiler is making you do dumb things, so to speak, because you know what you're doing is correct, but the compiler is forcing you to be more verbose about certain things, or not permitting you to do certain things, although you know that at runtime this could perfectly work. So that's the downside of it. Personally, I believe that a statically typed code base is easier to maintain over the long run. At least you wouldn't require so much discipline or guidelines of people working on the code base.
Yeah, I think I agree with your explanation. And I know we're up against time, but I find it fitting that such a popular language has come out of a company that builds tools for developers and obviously has an intimate understanding of what a developer wants and the subtleties there. Have you reflected on that? Was it any surprise to you, or was it easy for the people at JetBrains to reach consensus on the ideas behind Kotlin, because you were like, oh, we've seen this so many times before, we should do it this way?
I think for certain features, it probably was, because it is, if you look at Kotlin and what a lot of people describe it as, is it's a pragmatic language that is trying to do away with the common pain points that you encounter when you're writing code in Java or C# or other languages. So I think there is consensus on a lot of the features that are introduced to the language, because it's something that not only us at JetBrains have suffered, but the majority of developers that are using these languages have encountered. With other things, it's not that easy, I would say, and it does require more work. Like, for instance, now with 1.1, we're working with coroutines, which is basically a generic way to implement asynchronous programming, and it requires more input from developers and seeing the pain points that developers have, and it fluctuates a little bit on how we're doing things and not. So I think it really depends on the type of feature that we're specifically talking about.
Okay, well, Hadi, thanks for coming on the show. It's been great talking to you about Kotlin.
Absolutely, very much enjoyed it.
Ad for Prize is an iOS app where users can create ads to win prizes. Companies post these prizes as an incentive for people to make ads. If you're a creative person and you love to compete, you will love Ad for Prize. Check it out on the iOS App Store. Only the most creative advertisements win the prizes, like $150 cash or $100 gift certificates to your favorite retail companies. With Ad for Prize, I am trying to change the way that online advertising works, and I'm currently hiring an iOS developer to lead the engineering of Ad for Prize. If you'd like to work with me, send me an email, jeff@softwareengineeringdaily.com, and if you have an iOS device, check out Ad for Prize, ADFORPRIZE, Ad for Prize, one word. Check it out on the iOS App Store, and I hope you continue to listen to Software Engineering Daily.